Hi everyone, good morning. So today we're going to be looking at a new topic. We're going to be doing junior math today, and our topic for today is Pythagorean theorem, or you can say the Pythagoras theorem. Okay, so we're going to be looking at something nice. So just hold on and try to understand and try to follow. It's very easy. Okay, so but before that, I want you to do something quickly for me. Okay, I want to show you a riddle and I just want you to try to figure out what the riddle is about or what the answer is. It's not math related anyway. Okay, so before Mount Everest was discovered, what was the highest mountain in the world? Before Mount Everest was discovered, what was the highest mountain in the world? So by the end of the class, or toward the end of the class, I'll let you know the answer. But think now in your mind. Okay, just think in your mind and see if you can get the answer. And towards the end of the class, you'll find out if what you thought was correct or not. Okay, so that's our reading. Okay, but let's go now. Okay, so let's review something. There are some things you need to actually know or remember before you can move into Pythagorean and the Pythagorean theorem. You can't just start it without remembering some of these things. So I want to just show us that. Okay, so first of all, you need to remember that squares and square roots are a part of the Pythagorean theorem. It's something you have to know. So I think most of us will remember that, but let's just look at one or two examples on that. So what if you ask to find the square of 5, for example? That's a simple one. To find the square of a number, you just need to multiply the number by itself. Okay, that's how to find the square of a number. So 5 squared simply means, okay, 5 times 5. Okay, so 5 times 5 is 25, and that's just it. That's very simple. So any number you're given to square, remember that all you need to do is multiply the number by itself. Okay, now let's look at something else. What about square roots? So you're asked to find the square root of 81 now. You want to find the square root of 81. How does that work? How do you do that? Okay, now I want you to remember that when you're dealing with square roots, you have to find a number now. Now, when you multiply that number by itself, it gives you this number in question. So we are looking for a number that when we multiply that number by itself, should give us 81. Now, there is another method you can use, which is the repeated division method. So you divide and then you pair, but we're not going to go into that. That's a topic on its own. So find the square root of 81, and then the answer here is 9 times 9 gives 81. So, of course, square root of 81 is 9. Okay, so I just need you to remember how to find squares and square roots. In fact, if you can learn some of these squares up to maybe 40 or as far as you want to go, it will help you. It will help you. Okay, so let's move on. Let's move on. Okay, but before I go into anything, I want to tell you a story, and it's about Pythagoras. Okay, so let me take you on a journey. Now, a long time ago in a land far, far away, there lived a man actually, and he was called Pythagoras. So this is not 2005 or 1996. This is a very, very, very long time ago. Okay, very, very long time ago. Okay, now who is this man and what is his life? What was his life's work about? Okay, so this is just a picture of Pythagoras. Okay, just an old picture of him. Now, he was a Greek philosopher, so he wasn't just a mathematician. He was into so many things. Okay, he was into so many things. But there's a reason why he's named that the most important thing we know him for in math. That's what we're going to discuss today. So he was a Greek philosopher and he was a great mathematician. Okay, he had many writings. He taught a lot of people. He was versatile and all of that. So this is just a picture of him teaching some people. Okay, all right. Now, what exactly is important about this man? Okay, why do we spend time in school learning about somebody, this man? Why do we learn about him? So let's see that. He came up with a theorem, okay? He came up with a theorem, and we now call that theorem Pythagorean theorem or Pythagoras theorem, okay? So the theorem is named after Pythagoras, okay? So now he went to Egypt in a let's just say he discovered something. Okay, he discovered something. So when he was there, or how he discovered it was that he observed some people using a loop string. You can see the loop string by the right side there. They used it. It had 12 knots, and they were using it to verify a right angle. Okay, on one side it had 3 knots, on the another side it had 4 knots, and on the longest side it had 5 knots. And they were using those that string to show that, okay, this forms a right triangle or a right angle in that triangle. Okay, now, so after he saw that, he was inspired. He got an idea. He got some knowledge from so many of these things that he observed, and then he stated that in any right angle triangle, okay, in any right angle triangle, that's where you have the sides A, B, C. Okay, C is usually the longest side, and we call C the hypotenuse. So Pythagoras stated that in any right angle triangle, okay, the square of the longest side, which I already told you is called the hypotenuse, the square of that longest side is equal to the sum of the square of the other two sides. Okay, so he was observant, he was curious, he was a researcher, he was everything. And then he said, okay, yeah, I noticed that the square of the longest side, which is called the hypotenuse, is equal to the square of the other adjacent sides, the sum of the square of the adjacent sides. So we can now write that as, okay, a squared plus b squared equals c squared. Now, this is just an assumption for the triangle ABC. You can have another triangle XYZ. You can have any letter you want. You know, in mathematics we love letters. Okay, so this is just a triangle ABC. So a squared plus b squared equals c squared now. Okay, so that was the theorem that Pythagoras actually stated. That was named after him. Now, so look at this. If we go back to that observation that he made in Egypt, where he saw those people using the loop strings, you'd see that if you draw a square on the side 3 and draw a square on the side 4 and draw a square on the side 5, the square on the side 3 plus the square on the side 4 actually will give you the square on the side 5 if you draw it. We'll get back to this. I'll give this to you as an activity you can try out. So a squared plus b squared equals c squared. That's what I want you to understand, okay? Then as time goes on, you would even be able to prove it yourself. Okay, now, so long story short, now, there's something you need to know. Pythagoras did not necessarily find this theorem, but there have been so many arguments that he wasn't the one that found it, wasn't this, it wasn't, but the point is that he was the one that announced it. He discovered it and discovered it from other people and announced it to us. So the theorem is attributed to him. I don't know, I wasn't living in those times, so I cannot tell you per se that, oh yeah, he did this, he did that. But the truth is that we know this theorem as Pythagorean theorem, and nothing is going to change that, okay? So now, let's take some examples. We've been talking about the theorem. We've said, okay, a squared plus b squared is equal to c squared, and c is the length of the hypotenuse. Now let's see how to apply this in real life. Or let me see, we can apply it in real life, but maybe not in this class. I would show you another application as we go. But let's just look at some examples. Now, let's try an example. Find the missing side in this triangle here. Look at that triangle here to find the missing side. Okay, some people are already shouting, oops, how are we going to do this? Oh no, mathematics is here again. How are we going to find C? What is A? What is B? What is C? Okay, so just take a deep breath and calm down. We are going to get it now. Okay, so we have 8, 6, and C. Okay, so let's look at that now. First of all, you need to remember that our theorem is what we're going to use. So you just have to remember it, okay? A squared plus b squared equals c squared. There's a song on YouTube, actually, on this same YouTube that actually is a danceable one that you can dance to. Okay, you can try and check it out. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared plus b squared. So if that will help you, you can actually sing the song also. Or you can even form your own song and it will help you remember the theorem. Okay, remember that C is the hypotenuse, the longest side. Okay, so in this case now, from Pythagoras theorem, we can say that since C is the longest side, in this case also, C squared equals to 8 squared plus 6 squared, or 6 squared plus 8 squared, anyhow Right, it's the same thing. So 6 squared equals to 6 squared plus 8 squared. So we have 36 is the square of 6 and 64 is the square of 8. Okay? So 36 plus 64 now gives us 100. And then that is not what we're looking for. It's just, we're just getting there. Our question is find C, which is the missing side. So remember I told you that you must be familiar with squares and square roots. So to find C now, what you're going to do is to find the square root. Okay? So you're going to find the square root of C squared, which is C, and square root of 100. So C equals to the square root of 100. Now, let's go back to memory and let's see what's the square root of 100. Okay, 10, right? I think it's 10. Yeah. So C equals to 10. Okay? So this is a very simple example that I want you to at least grasp as quickly as possible. Now, we're going to move on to something more complicated. Now, you might not always get something this easy, but no matter how complicated it looks, I want you to be able to solve it. So let's look at this. Look at this. Don't panic. It's easy. It's easy. Don't say, oh, this looks so big. No, it's not so big. Your brain actually can process this. So try. Let's go. Now, we have to find X and Y, right? We have to find X and we have to find Y. Okay, but we can't. Now, in life, you have to take things one step at a time. So you can't find X and Y in the same step. So let's see which one is easier for us to find. Now, if you look at this diagram, it's a mixture of triangles. Actually, there are 3 triangles here. There are 3 triangles here. We have a small right angle triangle, or another triangle that is obtuse. Okay, it's obtuse and angled, and then we have the bigger one. Okay, let me just see if I can show you what I'm trying to say. Okay, so this is our triangle number. Okay, this is our triangle number 1. This is the first one here. This is the first triangle here. Now, this is the second triangle here. This space is the second triangle here. Now, the last one is the big one. The big one, okay? The big one is the third one, okay? Now, the second one that I just showed you, we're not going to use that. We're going to be dealing with right angle triangles. So we're going to be dealing with the small right angle triangle and the big right angle triangle. Okay, so let's take it easy. I will show you how to do that now. Okay, so the first one we're going to do with, look at me. Let's go. Don't worry, it's simple and easy to understand. So this is our triangle, initial triangle. Now we're going to say goodbye to this. Let's say goodbye to this triangle. Now I'm going to bring just that small one. Just the small. Let me go back and show you again. This is the big one, right? This is the big one. Now we are saying goodbye to this big one, and we bring in the small, the first one, the small right angle triangle there. Okay, so now this is easier if you ask me. It's not something to be frightened about. Okay, but remember what we're supposed to use. Our theorem is a squared plus b squared equals c squared. Very important, very important. Okay. So in this case now, I can see that, I hope everyone can see that there's not a per se, we just have sides and one missing side called x, okay? Now what I want you to understand is that you should be able to identify the hypotenuse. How do we identify the hypotenuse? Number 1, it's the longest side. That's the most common way to identify it, is the longest side, okay? Or in a case where the triangle looks a bit sketchy, it's the side that is opposite the 90-degree angle, the right angle. The side opposite the right angle is the hypotenuse, or the longest side, okay? So in this case, I think everyone agrees with me that the longest side here is 17, right? If you're following me, you should be able to tell me that the longest side here is 17, okay? And it's the side opposite the 90 degrees. I hope everyone can see the 90 degrees, the 90-degree angle. So we are looking for x, meaning x is one of the other 2 sides, one of the adjacent sides. So our formula should look like this. From Pythagoras theorem, x squared plus 8 squared. So we are adding the adjacent sides now and equating it to the hypotenuse. Okay, so we have x squared plus 8 squared equals 17 squared. So just know that the hypotenuse is in a league of its own. It's on its own, it's equal to the other 2 sides. So put the other 2 sides, square the other 2 sides, add them together and equate it to the square of the hypotenuse. Okay? So x squared plus 8 squared equals 17 squared. Okay, I think it's not so hard. Okay, now the next thing we need to do is, okay, follow me. Balance is important. There are two ways to solve this anyway. You can decide to subtract 8 squared from both sides, but I usually say let's take 8 squared to the other side. Okay, so x squared becomes 17 squared minus, now instead of plus this becomes a minus, or you're subtracting from both sides. So minus 8 squared. So 17 squared minus 8 squared. Okay, follow me, follow me, follow me, follow me. So x squared now, what is 17 squared? That's what I said. Try to be familiar with the values of squares. You can learn as much as 20, up to 20 square, up to 30 square, as far as you can carry yourself. So 17 square is actually 289, and 8 square is actually 64. Okay, so that helps us out. So x squared now becomes 284 minus 60, 289, sorry, minus 64, which is 225. Okay, so what is x? Remember I said you need to be familiar with squares and square roots for you to survive in Pythagorean, in using the Pythagorean theorem. So x squared is 225. Okay, how do we get x? Okay, the simple way to get x is by finding the square roots. So find the square root of x squared, that is x, and also find the square root of 225, balance. So square root of the 225 is now our answer. So x is square root of 225. Now, what's the square root of 225? Oh, okay, yeah, it's 15. Yeah, 15 times 15 is 225. Okay, so square root of 225 is 15. So that is step one. We've been able to get x. You can see that big triangle. It wasn't needed right for this step. We just needed to take the small one and get our x first. Okay, so in math problems generally, you would see some problems that look very difficult at first sight. When you look at it at that first instance, your first thought is that this is too difficult. But it's not actually like that. Sometimes it just takes a little breaking down, separate components. I think you know what I mean by separating the components. If you're working with in the laboratory and you're doing an experiment, you know what components are and all. So separate the components. Don't just assume that, oh, I just need to jump into it and solve it. Break it down. Try to break it down. See, and you will be able to get it. Okay. So in this case now we've gotten our x, but that's not the answer. They asked us to get x and y. Okay, so remember our big triangle. In that big triangle, we didn't have x, right? Okay, but now we're one step further, we've gone one step further now. Okay, so we now know that our x is 15. Okay, that's a good one. Okay, so this is our triangle now. So if I want to redraw this, I don't need to put x again because I now know what x is. I now know that x is 15 after applying Pythagorean theorem to this small right angle triangle. Okay, so I know x is 15 now, and I can see that for the big triangle, BD, look at the triangle. You can see BC is 8, B to C is 8, okay? And C to D is 12, right? Okay, C to D is 12. Now, we now know that BC and CD, okay? BC plus CD is 8 plus 12. So we're going to get what? 20, right? So we're going to get 20. So our BD is automatically 8 plus 12, which is 20. I mean the total length of the big triangle. Okay, let me just show you so that in case you don't really get what I'm saying, you'll be able to understand me. Okay, so I'm talking about the length, the total length here now. Okay, the total length here. So BD, from B to D now is not 8 and it's not 12. It's the sum. It's the sum of the two. So that is 8 plus 12, which is 20. Okay. So now I'm going to replace. Can you see this triangle? I'm going to change it and give you a new triangle that you should actually use for the solution. Okay. So just follow me and try to understand. Okay. So back to that triangle. Now this is our new triangle. Okay, so remember that now we have our x as 15, Okay, we got that in the last one. And we have our BD as 20 because we know that 8 plus 12 is 20, right? Okay, now we need to find y. So we are back to just a single triangle, a small triangle, a normal triangle without all the complexities and all the long, you know. So sometimes it can be deceiving at first sight when you look at the question, but it's not difficult. So now we have to find y. Let's recall our Pythagorean theorem, and it states that a squared plus b squared equals c squared. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared. So that song is actually, I think it was a man that sang it. It's on YouTube also. I usually use it in class, so that's why I know it. Okay, so now let's get down to business. Remember that this is not necessarily A, B, but you know that A and B are the adjacent sides, and C is the hypotenuse, right? Okay. So our hypotenuse in this case is y, okay? So we have from Pythagoras theorem, 15 squared plus 20 squared equals y squared, okay? Now we can turn that around and say y squared equals 15 squared plus 20 squared. It doesn't change anything, okay? Now remember our squares, 15 squared is 225 and 20 squared is 400. Okay, so remember that and try to learn as many squares as you can. So y squared now is 625. Okay, y squared now is 625, and then y automatically becomes square root of 65. Square root of 65 is what? 25. So 25 cm is our y. So for that big triangle that you saw that was looking so complicated, x is actually 15 cm and y is actually 25 cm. So that is Pythagorean. That's the Pythagorean theorem. Okay, it's a simple one. It's a simple one. With practice, you get it faster. Okay, so let's move on and let me just tell you some things. Some fun facts to note. Did you actually know that in Egypt, there is some evidence that in the olden days, this Pythagorean theorem we're talking about, which wasn't called Pythagorean theorem then anyway, it was actually used in building pyramids. There's actually some evidence that in the olden days, this theorem was applied unknowingly. It had not been named then, but it was used in the building of pyramids. Also, in Babylon, a tablet, this is just a snapshot of the tablet. The tablet was traced back to Babylon, to Babylonian times, and if you look at the inscriptions, actually what the inscriptions are Pythagorean triples. They are Pythagorean triples inscribed on these tablets. Even though, as at that time, we didn't necessarily call them Pythagorean triples. So that is another evidence to this awesome theorem. Okay? So now, although Pythagorean triple, we're going to get to that in Pythagoras 2. This is the first class of Pythagoras, so we'll get to that in our next one. So Pythagorean theorem is very interesting and it's widely applicable. It's used in so many aspects of life. I would also give you some daily, or should I say life applications of Pythagorean and the Pythagorean theorem in our next Pythagorean class. Okay? So those are the fun facts I wanted you to know. So let's summarize what we have learned. Okay? First of all, Pythagoras proved the theorem, which was named after him. We all agree with that. And his theorem states that c squared equals a squared plus b squared, or you can say a squared plus b squared equals c squared. Either way is fine. Now, where, of course, c is the longest side, which is the hypotenuse, and a and b are the adjacent sides, or the other two sides in the right triangle. Okay, so you need to know what exactly C, A, B, what they stand for. So you need to remember that. So it's simple, very simple. Okay, very simple. So you can, of course, if you don't understand one or two things, you want further explanations or any help at all, you can just leave a comment and we can discuss further. Okay, but before you go, I want you to do something. So you're going to try, you can try this at home if you want to. It's a home activity just to prove Pythagorean theorem, so that it doesn't you don't just learn it, but you actually know how that theorem was, arrived at. So you can do this on a plain paper, on a white paper, or however you want to do it. So draw a right angle triangle with sides 3, 4, 5. Okay. So then you should draw a square on each side, as you can see in the diagram here. This isn't measured to, isn't drawn to scale, but draw yours to scale. Use a ruler, a pencil, and make use of enough materials to get your accurate diagram, okay? Now, so you draw a square on each side. Remember that the square, all sides are equal. So the side with 3 will have a square of 3, 3, 3. The side with 4 will have 4, 4, 4, 4. The side with 5, like that. So once you've done that, okay? Once you've done that, you should now divide each of the squares into small squares of area 1 cm squared. So you can see this, these are the big squares that you could have drawn, you should have drawn, or you are planning to draw. So the big squares, now you take each of those squares and use a ruler, measure accurately with a pencil, and divide each square into 1 cm squared. That means the length should be 1, the breadth should be 1. That's the small squares you're going to be dividing them into. Okay, so once you've done this, now what you now do is you count the number of small squares on the hypotenuse. Okay, count it. That's the first one. Number 2, you now go and count the number of small squares on the other adjacent sides, on the other 2 sides. Okay, now when you do that, you would now have to, okay, compare the value you got for number 1 and the value you got for number 2. Now, if you do it properly, if you do it well, if you do it carefully, if you do it accurately, okay, the value you got in number 1 should be equal to the value you would get in number 2. So the square, the number of squares in the hypotenuse should also be the number of squares when you sum the other 2 sides together. Okay? So just try it out. It's a fun activity. Just try it out. And if you're able to get it, give me feedback. Let me know if you were able to get the answer right. Okay? Let me know in the comment section. Okay? Now, let's see how many people thought about the answer right and got it right without checking anything. Okay, so before Mount Everest was discovered, what was the highest mountain in the world? The answer is Mount Everest. Mount Everest was the highest mountain as at that time. It was just undiscovered. It was just undiscovered. So Mount Everest was is still and was also still the highest mountain as at that time. Okay, so that's our riddle. I hope you got it. If you got it, thumbs up. Okay. All right, so this is an optional part. So if you want to practice, let's assume you're happy with what you've learned and you want to see if you've truly learned something, okay? You can actually go on the site I'm about to give you and try out the game. The game is also on Pythagorean theorem, and it's based on what I have discussed today. So if you want to try it out, you want to see, okay, did I actually learn this well? Did I actually understand it? You can go and try it out, okay? So you go to the website, quizzes.com, then you search for the title of the game. There is Mr. Pyth's theorem. Mr. Pyth's theorem, okay? So just search for Mr. Pyth's theorem. That's a particular, there are other games, okay? But this is the one I want you to play because I fashioned the questions based on what we discussed. So Mr. Pyth's theorem, search for it, and then just answer the questions you can see. Let's see if we've gotten something today. It's not compulsory, it's just if you want to have fun, nothing too difficult, something I believe you can all do, okay? So I wish you good luck with that. And I hope you actually understood all that was discussed. So like I said, if you have any comments, questions, something you want to ask about what we've said, I can actually reply to you. So just put in your comments and your questions and I'll get back to you on that. Okay, so in our next class, for junior math, we'll do the Pythagoras 2. We'll do that as the concluding class for this particular topic. There we'll treat Pythagorean triples and also see some real life applications of this theorem. Okay, something that you can hold on to that you can actually use. So that's what we're going to do in the next class. So it was nice talking to you guys again today. It was nice seeing you today. I had fun on my own here watching and talking to you. So I hope you guys also have fun on your own and give me feedback on what you don't understand or what you understand or how far I may be of help to you guys. Okay? So take care of yourselves. Have a lovely day. Bye. See you next week.